For number 5, I have the function written here that they gave us. I sketched a little graph of it because that helps me. They told me to rewrite the equation so that it has an x-axis reflection and we move it up 7 units. So if we're going to have an x-axis reflection, that means we're going to be multiplying by -1 and we're going to multiply outside. And if we're moving up 7, that means we're going to be adding 7. That's also going to be outside. So to make those transformations, when we multiply by -1 outside, you can write -1 times and then put this 10 in parentheses if you want to, or you can just write -1 times 10, or you can just write -10. All of those mean the same thing. Do not put the -10 in parentheses though. If you're going to put the 10 in parentheses, the negative needs to be outside of it. So then we need a +1 on the outside. So this is going to be to the x power, to the x power, to the x power, and the +1 is not going to be part of the exponent. It's going to just be down there. To find the y-intercept, we're going to take this equation. We're going to let x equal 0. So we have y equals -10 to the x plus 7. So y equals -10 to the 0 plus 7. Just 10 is being raised to the 0 power. So just 10 becomes 1 plus 1. Anything to the 0 power is 1. And then we have -1 plus 7, so y equals 6. So it's going to cross over the y-axis at 6. This makes sense because when we would reflect over the x-axis, we're going to be crossing through at -1. And then when we move up the 7 units, we would go up 1, 2, 3, 4, 5, 6, 7, and we're going to end up here at 6, 1 lower than the number of movements that we made. So it crosses over there. The domain is all real numbers. This function has no restrictions on its domain. It's exponential. And the range, after we make all those transformations, I've taken this and I've moved it up here. When that shifts up, this horizontal asymptote that was the y-axis shifts up with it. And it's 1 unit bigger than the y-intercept. So that means that the highest I go for my y value is 7. So my range goes to from negative infinity to 7, but it does not touch 7, so it's not included. For this one right here, again, this is moving up 3 units. So my original function would look like this with the horizontal asymptote right here. When it moves up 3 units, both the y-intercept and the horizontal asymptote move up 3 units. And so my new horizontal asymptote is at 3. And my function goes through the y-axis at 4. So my horizontal asymptote is the equation y equals 3. My domain is all real numbers. And my range is not going to get to 3. It'll get close. So it goes from 3 out to infinity. We do not include 3. Over here, I'm just going to write in the book, they wanted me to take this equation, 4 to the x, and shift it 5 units to the right. When we shift left or right, we're adding or subtracting. When we're shifting left or right, we're adding or subtracting inside of the function. So that's going to be in the exponent. Since we're going to the right, it's the opposite of what common sense tells you. So we're going to be subtracting 5. So when we write this new equation, our new equation is going to be 4 to the x minus 5. And then for the last one, I drew the original function on there. They want us to find the graph of the transformations. So this would be the original function. So you can see it's reflected in the x-axis. So we have an x-axis reflection. And then it got moved up. So where it originally went through, once we would have reflected over the x-axis, it would have looked like this. Whoops, I missed the intercept there. It would have looked like this. And then we moved this intersection point of the y-axis, which was -1 after the reflection. We moved it up 1, 2, 3 units. So up 3. So to show that in our graph or in our equation, we're going to have -2 to the x, and then +3 is not part of the exponent.